Hi everyone, welcome back to Chem Help ASAP. In today's video, we are going to learn how to draw Lewis structures for neutral atoms. Now, we will be using electron configurations and valence electrons, so if you need a refresher on those topics, please check out my other playlists. However, Lewis structures are named for the man who came up with them, Gilbert Lewis, and he did this while he was a professor at UC Berkeley. So automatically I am going to be partial to Lewis structures because I am a UC Berkeley alum myself. But anyhow, let's get drawing. Before we start, let's do a quick review on valence electrons versus core electrons. So your valence electrons are going to be in your outermost shell. These are the electrons that are going to interact with electrons from other atoms. And this is why, as chemists, we're so interested in the valence electrons, because this is where all the action is. Your core electrons are going to be closer to the nucleus, and they very rarely interact with other electrons from other atoms. So we are less concerned with how many core electrons an atom has and much more concerned with how many valence electrons an atom has. Now, to count up valence, we are going to need to do electron configuration. So let's do the electron configuration for chlorine right here. I will use the noble gas shortcut. So that will be neon, 3s2, 3p5. Now your valence again are in the outermost shell, so you want to look at these numbers that are before the orbitals, and you want to take the largest number is going to have your valence electron. So these are both 3s, so I just add the number of electrons up. Chlorine has 7 valence electrons. Knowing now that chlorine has 7 valence electrons, this is how we draw the Lewis structure for it. We are going to use the symbol for chlorine, Cl, and we are simply going to put 7 dots around chlorine. So 1, 2, 3, 4, 5, 6, 7. That is the Lewis structure for the chlorine atom. Let's do another example. Let's do magnesium. Again, I will start with the electron configuration. I will use that to find my valence. Magnesium is pretty easy. I have 2 valence electrons. So for my Lewis structure, it will simply be Mg with 2 valence electrons. Now, one thing I want to point out here is you will often see the valence electrons written on the left, but they don't have to be. I could also do the Lewis structure like this, or I could even draw the Lewis structure with 1, 2, like so. It doesn't matter as long as you have 2 dots representing the 2 valence electrons in magnesium. Okay, let's clear this page and let's do some more examples. Let's take a look at selenium. Again, I'm going to start with the electron configuration. That will be argon, 4s2, 3d10, 4p4. Again, for the valence, what I'm looking at is I'm looking at the largest number in front of the orbital. So that means I will not include the 3d electrons. So I have 2 plus 4, I have 6 valence electrons. So my Lewis structure looks like this. 1, 2, 3, 4, 5, 6. Again, you can put these 6 dots in any order you want. I just tend to work from the right side around. Let's do a really simple one. What about hydrogen? Electron configuration 1s1. So hydrogen's Lewis structure looks just like that. So you can go from the very simple to the very complex. Let's do just one more example. Let's do xenon. And the electron configuration for xenon is krypton 5s2 4d10 5p6. Again, for valence, I'm going to drop the 4Ds. I have 2 and 6. I have 8 valence electrons. So the Lewis structure for xenon looks like this. A word to the wise: when you are doing any kind of Lewis structure, make sure your dots are very clear. Often I will get student papers to me where the dots are so large they kind of blur together, or they're so tiny you can't even see them. So just make sure you're communicating very clearly in your Lewis structures. Now, obviously, we can do a lot more with Lewis structures than just neutral atoms. And in our next video, we are going to talk about Lewis structures for ions. Thanks so much for watching.